Hi guys, hope everybody's doing well. In terms of the counting principle problems handout, the questions that are usually asked of me, students want me to take up questions 8, 9, and 11. So I'm going to look at those for you today and give you a solution just in case you were struggling with them. Let's take a look at number 8. If we look at 8, it says a female tennis star has 42 tops, 24 skirts, 19 shorts, and 28 tennis dresses. Obviously, they wouldn't wear a skirt and shorts at the same time, only one or the other. And it doesn't need either of those or short if you're choosing to wear a dress. How many different outfits? Okay, so let's think of all of the possibilities of outfits. The tennis star could wear a dress, or she could wear shorts and top, or she could wear a skirt and top. So let's notice the choice of our words too. We're well aware now that or means add, and we're well aware that and means multiplication. So let's start with dresses. How many choices does she have available to her for dresses? Let's start with shorts and top. How many choices does she have available for shorts? How many choices does she have available for tops? Notice that we're multiplying with the and. How many choices does she have available for skirts? And how many choices does she have available for tops? Again, notice we're multiplying with the and. So 28 plus 19 times 42, 798. 24 times 42, 1,008, for a final answer of 1834, 1,834 possible outfits. Okay, this is a beautiful test type of question because it's mixing both the and the or ideas. Fundamental counting principle. Let's take a look at question 9a, another really good test question. How many two-digit numbers can be formed using the digits 1, 2, 3, and 4? So with digit questions, what I like you to do is I like you to think of the digits, you know, when you were little and you had the wooden blocks with the A, B, C, D, and whatnot on them, and you also had a set of the wooden blocks with the numbers. I want you to think of the digits as little wooden blocks, and you're throwing them into a beautiful bag, shaking up the bag, and then drawing out of the bag how many you're looking for. So in part A, it says how many two-digit numbers. That means that your hand is going to go in the bag and you're going to draw out 2 digits. Now, it also says if you can repeat the digits. So hold on, envision this with me. I have 5 wooden blocks, 1, 2, 3, 4, 5. I throw them in a beautiful cloth bag. I start shaking it up. I ask you to put your hand in the bag, so your hand is swishing around the bag. How many blocks do you feel right now? 5. I ask you to pull one out. You pull it out. You look at it. I ask you to drop it back in. because we could possibly have repeat digits. You drop it back in. I ask you to make a second pull, a second draw. So your hand is swishing around the bag. How many blocks do you feel? 5. How many possible 2-digit numbers could there be? 25. Now watch how this can be a little bit different. You're still working with your 5 digits, 1, 2, 3, 4, 5 wooden blocks, except part B says each digit can only be used once. So you're still going to pull out 2 blocks. So put the blocks in the bag, shake, 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 hand goes in the bag. How many blocks do you feel? 5. You pull a block out, you take a look at it. Maybe you put it on your desk, maybe you put it on the floor, but you definitely don't put it back in because each digit can only be used once. So when your hand goes in for the second pull, how many blocks do you feel as your hand is swishing around? 4. 20 possible 2-digit numbers. Okay? Both of these questions are really good test type of questions. There's always a digits question. There's always a question with both and or mixed in. All right, let's take a look at question 11. Question 11 is also a very good test question. A team of students is being chosen to represent Eastwood in a mathematics competition. The team must consist of 1 student from grade 9 or 10, 2 students from grade 11, and 1 student from grade 12. So obviously it's a 4-person team. Now, there are 5 kids in grade 9 that are interested in being on the team, 2 kids in grade 10 that are interested in being in the team, 2 kids in grade 11 that would really like to be on the team, and 4 kids from grade 12 who'd also like to be on the team. Okay, so let's think about this, and let's start with our grade 9 and 10 kids. How many options are available to me for 1 position? Well, I've got 5 grade 9s who are interested and 2 grade 10s that are interested and putting their name out there that they want to fill that spot. So I've got 7 people that are interested. In grade 11, there's only 2 kids that are interested, and there are 2 spots. So those kids are in. It's sort of like running in student council, and let's say somebody's running for secretary and there's nobody else running against them. They're in. Okay, let's look at grade 12. Only 1 kid can go to the conference, but I have 4 kids that are really interested in going, 4 kids that are vying for the position. So that means that I've got 4 choices. So 7 times 1 times 4, 28 possible teams. Hope this was helpful. If there's anything else you need, don't hesitate to let me know. Thank you.